Happy Friday and welcome to the eBPF and Cilium Office Hours live stream, also known as eCHO. My name is Donia. I will be your host today, and this is episode 193. And I'm very excited about the topic we're going to be talking today shortly. Benchmarks don't lie, the security agents cost, or is it eBPF? Please say hi in the chat and from where you're joining us. I'm very excited to see who is there today. And I'm in the south of France and it's very sunny today. So before getting into all the topic, exciting things we're going to talk, I have a few news I wanted to make sure everyone is aware of that got published in the Cilium, in the biweekly eCHO newsletter. If you're not subscribed, please subscribe. You will have all the news biweekly, as I just mentioned, around eBPF, ecosystem on the technical side, all the projects, and more. I wanted to highlight a few news. The first one is eBPF Foundation announces community and advocacy fellowship program, and I'm sure there are many eBPF contributors here. It can be about code, documentation, even community. If you are actually a contributor, you can apply. There is a specific program goals, and there is a monthly stipend of 1,500 USD dollars. The only thing you should maybe know, if you're already paid to work on eBPF full time, you cannot apply. Otherwise, the deadline is September 19, and if you have any question or you want feedback, you can contact Bill Mulligan, DM him. I'm sure he would be very happy to help you and answer all your questions. The second news I wanted to highlight is Cilium at KubeCon and Cloud Native Con North America. All the collocated events are now live on SCAD, and there are many talks around Cilium. So it's going to be very exciting. There is CiliumCon on day 0, and there is also some talks at collocated events. I will be giving a talk, and I will be very happy to talk with you and meet you if you're in Atlanta in November. And the one you don't want to miss is the 10 years of Cilium. It's going to be very exciting to see all the things that happen in 10 years. So the latest news, which is not the least, is that AWS announced expanded support for Cilium with Amazon EKS hybrid nodes, and there are many new features that are actually supported now. So if you're running EKS hybrid nodes, I'm very excited to hear about it. Hi, Ganitak. Welcome to the show. Where are you coming from? So now that you have all the latest news, I'm very excited to introduce you Henrik, which is who is actually a CNCF ambassador. He's also cloud native advocate at Dynatrace, and he owns a YouTube channel, Is It Observable Media, where there are more than 150 videos about any topic you're looking for around cloud native. So thank you, Henrik, for joining us today.
Thanks for inviting me. I mean, like I said in LinkedIn, when you reach out to me, I say, so I've been following eCHO livestream many years ago when I started to dig in Cilium or Tetragon or what any of solutions that you're relying on eBPF, and I was basically being in one of the attendee, watching the live stream. So today it's an achievement for me, to be honest, to be in front of the camera and not behind the screen. So that's I mean, I'm still behind the screen, but I have a different seat for sure. And also something you mentioned, 150. I didn't pay attention on the number of episodes. 150 episodes. Gosh, I've been doing a lot of videos. I didn't realize that.
That's very cool. Thank you. Okay, so let's deep dive into the topic today. So you did amazing benchmarks about runtime security agents, and today we're gonna check and see what is it about and what the data means today. So I wanted to ask you first, why did you want to actually dive into this topic first? And if you had any assumption at the beginning when you started working on it?
So it's an excellent question, to be honest. So in fact, I did two version of this benchmark, and both basically was an excuse to deliver a talk. But initially, when I started this benchmark, it was not. It was, yeah, of course, I wanted to to talk in KubeCon or other this conferences. But the main reason behind this was I had customer using Falco, others were using Tetragon, and there was Tracy from Aqua that was used in some accounts as well, and I'm not I don't consider myself like a security expert, and I thought, okay, but what is the actual differences? What does it mean from a user perspective? Utilizing one product or the other, what's the advantage to of one product or the other? So that's why I say, okay, let me dig in first. I started with Falco. That was a natural choice, and then switched directly went to Tetragon. And I can talk about Tetragon about a few things if you let me want to. but and then I discovered that this Cube Armor was out there, so I added Cube Armor, and then I added Tracy, and that was my first benchmark that I did. I shared the results in Cube Console Salt Lake City, and then one guy in the room, it was a pretty funny story because I explain the benchmark. I go through all the various content there, and then someone very into security. I know the guy, so it's Ben from Armo, and he asked a question. I say, "Oh shit, I'm not a security expert." He's going to ask a very deep dive question on security. It's game over. And then he asked a few things about security and how I did my benchmark and everything. And I say, and then when I finished the talk, I say, "Oh, gosh, I should have focused more on security because it seems that I didn't cover it pretty well." And then he naturally went to me and say, "Hey, we need to do another version. Do you want to collaborate?" And I add the benchmark on the security aspects, and you do the rest. And I say, "Yeah, great." And so that's why I did the second version, because Ben's I would be covering the more the security angle that because he has a very significant background on the security, which I don't necessarily have. So that's why we joined forces to build this second edition of the benchmark. In fact, I didn't share the results on my YouTube channel. I shared the first result for the first benchmark, but then I didn't do for the second one. So maybe if people are interested, it could be an excuse to
Do
recreate it.
another video.
Yeah,
Cool. Very cool. It's always interesting to see that when you get to conference, actually interacting with people with new ideas, and there is this emulation about new topics. It just pushes you to learn more and share more, I guess, with people. So that's very cool.
yeah.
Okay. Okay, so now that we know why you did it, maybe you can explain to us which agents you have been working on, what are the workloads, what is your setup, and how did you actually set up all your cluster and everything to do your test, and
Sure,
maybe
sure.
what you wanted to measure.
Yeah, sure. So maybe I can share my screen.
Sure.
So that will be so I'm using it's the layout of the KubeCon talk. So yeah, I try to do talks with themes for those who. And here was the following the theme of the Avengers, because here was like the who was the best security heroes in the market. So that's why in the like I mentioned before, in the second edition of the benchmark, on the first one I added Tracy from Aqua that has also using eBPF. So I selected only eBPF runtime security agent, and as you know, to fulfill the runtime security feature, uh, you need to be able to detect things. It's a bit like having a camera in a hotel or a camera somewhere else. So you have a camera, and the camera is here to detect suspicious events. And then if you add the camera plus AI, then you can say, oh, this is not normal, and that's exactly runtime security agent. So the idea is to detect any process spawn, any file access, anything, and eBPF was the backbone, the core of those individual solutions. On the second round of the benchmark, I thought let's focus on only toolings or solutions that are in the CNCF landscape and that are, basically an official CNCF project. So that's why I selected naturally Falco, Tetragon, CubeArmor, and the last one was CubeScape. Even if CubeScape is not doing only runtime security, you will see that I will share some numbers. It does way more features behind the scenes, but he has a runtime threat detection feature. So that's why I thought, oh, let's add this into the story. So Falco is the oldest. Tetragon is the young, or not young, because now it's been 10 years. I didn't realize it's already 10 years. Gosh. And then you have CubeArmor, and CubeArmor is the youngest one. And so that's why I picked those four solutions to cover the benchmark. So I'm not going to cover all the details of the benchmark that I did, because the idea of the benchmark was to cover the configuration aspects, to cover the observability aspects, because at the end, from my perspective, if you are in the security space, all those security agents, they are emitting or producing events, and so they are kind of an observability solution. So, or it's a pillar of observability. So they are producing something, and then you want to collect that. So that's why I think, from my perspective, those security solutions needs to be aligned with observability standards, so then you can easily consume the data produced and get details, and report them anywhere you want. So now, because we're not going to focus on a full benchmark, it doesn't make sense. I wanted to walk through what I've done to execute this benchmark. What I've did is that in the performance, we're going to focus mainly on the performance aspects. In the performance, I said, okay, we have agents that runs as an eBPF agent. So as if you're following eCHO, you know what is eBPF and what it means. So it means that it's supposed to not consume on the user space, but sitting in the kernel and detect in a very smart way things. And on the paper, I thought, okay, on the paper, there's no reasons that it could have an impact to end users. So that's why, okay, first, my first objective say, okay, does security agents really put zero footprint on the performance of our applications? So that's why I said, okay, let's measure the latency. That was my first objective through that benchmark. Then the second aspect, and in fact, on the first version of the benchmark, I wanted to first and second, I wanted to measure the resource utilizations of those solutions to get the actual footprint in our Kubernetes clusters. And but on the first benchmark, I only focused on the actual resource usage and memory usage, and because I didn't, I realized later on that it was a mistake when you deal with Kubernetes. If you just look at the usage of your workload, you're using any observability solutions that rely on kubelet, then you're just looking at the user space of your nodes, and then you don't even see what's going on the kernel. So that's why on the second version of that benchmark, I've decided to add the eBPF footprint, how much CPU time we're consuming on those probes, how much memory I'm consuming to exchange data, so through BPF maps. And then that could explain maybe why we have an impact slowly on the latency. So one thing that was a bit difficult when you deal with those solutions is that they are not equal. If I want to make it short, Falco is straightforward. It has a default rules covering most of the threat detections. Of course, you can customize it. The experience of customizing it could be discussed, but at least if you are a new user in the security space, you don't have to configure that. That was one of the advantage. The second one is CubeScape, that has the similar experience. When you install it, it has a 70 or plus, I don't remember the number of rules. They have probably extended it. That are pre-deployed, and they look at a lot of things. So at the end with CubeScape, you don't actually configure your policies. So you deploy, you have it, that's it. And then you have the two other solutions, Tetragon and CubeArmor, where here you get the engine. I mean, maybe it has improved. I didn't check recently on Tetragon, but at least on the few months ago, it was the case. You have the engine, and then you have nothing. So if you want to actually have security policies, you have to build your policies. And then same thing for KubeArmor. You deploy, and then there's nothing. So you have to actually build. So what I decided is to build few rules on each of them. So one about the service account files, any access to sensitive files, any egress communications, any installations of solutions in the cluster, yeah, stuff like this. I tried to map as I could in the time frame I had all those policies on each solutions to be able to compare it.
Just one,
Yeah,
sorry, can I ask you just one
of
question? It's so you have different network policies. I know that the semantic is very different from one to another when you're writing actually the policies. So I was wondering, how did you manage to actually have equivalent behavior?
So that is as it's an excellent question. It's very difficult to measure because at the end the act's slightly different. So I try to build. So I would say that KubeArmor, I wanted to have extra rules to match to Tetragon, but I had a service mesh, and at that time they have improved it. At that time they were looking at the pod level, so you cannot exclude. Let's say I don't want to have the envoy proxy considered, and that would putting so KubeArmor at the end was putting a mess everywhere when I started to do more complex things. So that's why I started to remove to at least be able to put load. That was my intentions, but I try to build as much policies that could reflect um, yeah, potential attacks, potential suspicious behaviors, I would say.
Okay.
um, and also I side of that I can explain later on with the architecture. I intentionally build some bash scripts that try to reach out, connect to a container, to a pod or a container, do some installation of packages, read some. So I intentionally did those events in the background because my intention was say, do I see the event? Do I can I catch the event? Because I'm doing something suspicious. If I have those tools, I may expect that they detect that. And surprisingly, sometimes it doesn't. I mean, I'm not going to tell which tool, but there are tools that didn't capture activities that I did. So because I mean, again, I was running within the cluster, and probably they expect that something is outside the cluster that does those type
Yeah,
of events.
that makes sense. Okay.
So to be able to compare, I I had to run a significant number of tests because at the end, yeah, you need measurements. So it's not one cluster with everything, and then you try to compare. You have to spin up clusters, restart, rebuild it, so different deployment scripts. So first to get the baseline with nothing, I did no agent, no security agents, just the app, and then measure the actual latency. And then Falco that has already the rules, so no differences. And then Tetragon, I have Tetragon with when you deploy it, it produce default events on the process started and ended. So I did just Tetragon with just the events, and then I applied the policies. KubeArmor, in fact, here you can see 3 tests. In fact, it's almost 8 or 9 tests because it has this KubeArmor. When you install it doesn't have any policies. It doesn't produce anything. It's completely a solution that sits in consumer resources but doesn't do anything. But then if you want to build your policies, you will have to produce events, and you have to turn on what type of events you're interested. So I want to have the file, the network, the capabilities. So you turn on the events that you are interested in. So I did combination of a test with 1 event, 2 events, and so on to see how it impacts, and then with all the events enabled, and of course with the policies and without the policies. So that's why there's so many different tests with KubeArmor to see if one sets of configuration has an impact or not. And last, Kubescape. Like I said, there's the default policy. So I just triggered that simply like this. To be able to compare things, I decided to do two type of tests. By the way, why? So I have I spent all my career doing performance engineering, so that's why the benchmark was so natural. That could be also an answer for your question. So I've
That
been
makes
using,
sense.
so I've been testing, comparing, tuning, optimizing things since more than 15 years. So that's why I have that normal way of doing this type of configurations. So I thought, okay, I want to do a constant load. So constant load was I have an app. I picked and choose. I have several apps, but in this cluster, but I do a constant load with 50 concurrent user per applications, and the load is stable. And I try to have
Okay.
like a stable state during at least 30 minutes, so then I can measure how the environment behaves during that time frame. Then I did a load test. In fact, in this particular case, because I did different load tests and different solutions, it didn't have any impact. So I'm not focusing so much on the load test, but I still did that load test as an extra bonus, I would say. But I won't share those results. So here the idea is that every 30 minutes I'm adding 50 user on each of those applications. So it means that every application deployed has 200 users after 90 minutes. So it means that we have three applications. We have 600 users that interact with those systems in the background. So that's the type of test. And then on the architecture side, so that's the second version of the benchmark. I intentionally removed service mesh because of the complexity that I had with of configuring kubearmor. So I used nginx ingress. And by the way, now if you want to use this, don't use nginx, but use traffic instead. It will be more secure. Then I use the OpenTelemetry demo. So if you're not aware of this application, it's the community demo that has been built by the OpenTelemetry project to demonstrate all the different protocols. So you have in total 12 or 15 microservices. I don't remember the actual numbers. And you have a small load testing component. And then I use Hipster Shop, which we don't see here. It's a microservices demo that Google built a few years back. I have an Unguard. Unguard is an app that is intentionally built and secured, and then there's cron jobs that try to do suspicious things on this app, like SQL injections, like every type of hacker attack that you may could happen. And then I have a Goat app namespace where I have those cron jobs where it's bash. There are pod starts and then try to randomly run like a attack, or not attack, but I'm taking control of the pod. I'm installing packages. I try to sniff the network. I do things that should be considered as suspicious. And last, we have the namespace for the solution. So Tetragon, kubearmor, whatever, you name it. And last, I have a last namespace is Gadget, Inspector Gadget. So you will see that Inspector Gadget has a very important, is going to be very important, simply for one reason: to measure the eBPF footprint. And I will explain it more deeper on how it works. So let me
I
just
just have one
yeah.
question before we move forward, if that's okay. Um, why did you separate and isolate all these components in different namespaces?
Because from my perspective, this is how users and how you design. So if you have an app, it should be in one namespace, and I don't put everything in a single bucket. And also because I want to, if I put, if I want to capture potential network intra namespace communications, then it's going to be that way. And also, it's a good question. I never thought about putting everything on a namespace in one single namespace. I always create different namespaces because I need to be structured. Otherwise,
Yeah,
it,
I
it makes you stress.
Yeah, I understand. My question was actually intentional because I guess that the best practice is to separate. But I feel like sometimes it can be also at the same play in the same namespace. For example, here your unguard is in a separate namespace, but it could be in the same app if there is a malicious behavior inside the same namespace. And I was wondering if it could have an impact on the benchmark, for example.
Oh yeah,
So
see.
that's why. Okay.
Good
Anyway.
point. Good point. I didn't catch that. Yeah, that's a good point. Um, so for those who wants to rerun this benchmarks, here is the repo to the where they have all the different files. And by the way, I have they have a 6 second. So that's the V2. So the V2 is using Kubescape instead of Tracy. So you can dig into that, and if you want to replay, there's all the steps to achieve it. But again, if it's a rainy weekend and you want to burn credits on the cloud, go for it. I
Okay.
go for go for it.
Good to know.
Um, no, so let me. I wanted to share the results, so I'm going to open. So it's results coming from the past. So let me. I need to bring the. It's another browser because I should have prepared that beforehand. Up here it is. Let me open here. Come on. Okay. Um, I hope it kept the filter because I'm looking at numbers because I'm not going to rerun. I didn't rerun everything because it take me a
Sure.
significant amount of time. Yes, it kept everything. So just to see here, I'm storing few dates to compare things. For some reasons, I saw that there's the comparison. I don't know why. I looked at the numbers. It doesn't work for some weird reason. So I didn't have the time to but I have another tab where I can look at the metrics, not in this overlaid, but in different time frames. So we can jump into that. But look, let's start with the response times. So you can see that the blue one is the no agent. You can see that it's about 20 milliseconds, 19 milliseconds, about that. So I have a oof, something is wrong. Oh, it's not the right time frame. So yeah, I think it's 9:30 p.m. on the 13th. Let me put. It was.
In the meantime, if you have any question, please type in. We will take them afterward. And also, all the links that Henrik is showing us are in the HackMD notes.
Well, I need to figure out where Cubescape was. I think he was on the. It says, Let me show you the thing, but I have an eBPF. I think it was on the 11th. Let me.
Sure.
11th or 12th. Let's put the 12th. No, it's the 11th then.
We have a question actually from Ganis Hack. How fast can a bucket interact with the other one? I guess you mean maybe a namespace. And I think that we will might be able to answer that with numbers after that you will be
No,
showing. No?
no,
Okay.
no. So what I was wanting to show you is this piece. Oh, put like this. It's the latency of so of the various solutions. So here we're looking at the test that has policies added on Tetragon. Policies added on Cubescape has everything. Keep in mind that Cubescape is not doing only runtime; it does way more things. And then Falco, and then CubeArmor. Here we don't have the events because I don't want to show them bad publicity. I can share the slides where I show the events. It's much more higher number than 60 milliseconds. But
Okay.
but you can see that already. So by the way, this is not per microservices. It's basically the front end. So you have the front end, and then the front end calls 13 different microservices. It's the actual total latency perceived from a user. So keep in mind that part. It's not on the microservices level. It's on the end-to-end level, on that latency. So you can see that Here we have the response times, and then I do a comparison, so I'm reporting the difference in terms of latency. So you can see that when you add those, there is a small latency introduced. Um, it's not big, but if you are into a very sensitive and performance oriented application, 13 milliseconds or 20 milliseconds could be perceived as way too much. So it
Yeah.
just really depends on the type of app that you're dealing with. Then on, I wanted to show you. I will jump to the other one because for some reason, like I said, the overlay doesn't work on that time frame. I don't know why. And I prepared. Was it this one? Yes, that's the one. So here you can see it's basically there's one time frame. Um, it's basically the various tests. Here is Falco. Here is Tetragon. This is Cube Armor, and that's this last piece is Cubescape. So starting with, let's start with the actual memory on the user space. So the memory usage, you can see that between Tetragon and Falco, it doesn't consume much. The one that is very high here in the user in the consumption is Falco Psychic. So that's the one that consumes much. The other one is very about 20, 30 megs. So it does nothing special. So you can see that Tetragon is consuming way more memory than the other one. The operator of Cube Armor is you see that the memory is changing over time. This is where there is nothing. This is where there's policies, and this is where there is policies and all the events. You can see that almost doubled or even more the memory consumptions on the user space of the operator. And then Cubescape, you can see there's different lines here. The one that is in top here is the node agent, which is responsible for the runtime threat detections,
Vulnerability scanning.
yeah, vulnerability scanning. It has also a component that scans the network policies, the network. So it does tons of things, and then produce tons of data from eBPF, store them into CRDs. So that's why it has a much higher consumptions than the other one, and then the rest is pretty much aligned with the other solution that we saw. Now, if you jump into the CPU, this is where it's get interesting. Falco has a reputation to consume lots of CPU, and yes, it consumes lots of CPU. It's you can see here it's the one that consumed the most in that benchmark, and then you have Tetragon. Tetragon is about 31 millicore. So on my first benchmark, I say, "Why Tetragon is a beast? Wow!" But you will see on the eBPF side. And then you can say Cube Armor. Cube Armor is like very low, and then when you turn on the events, it's like you can see that we started with about 20 millicore, and then we jump it almost to 150 core, and then Cubescape again, like I said, Node Agent is the one that consumed the most. So that's on the resource side, and then let's look at the eBPF CPU. That's one. That's InfluxDB. CPU time here. The CPU time. So if we map it to the first graph. So this area is Falco. So you say Falco is consuming about so it's in microseconds. So it's about it's a sum of everything. So it's not so much, but you can see that already compared Falco, Tetragon is consuming almost 8 times more. And then if you jump into Cube Armor, when it has all the benchmark, which is about here, you can see that it's consuming almost 2.5 times more than Tetragon. So it's quite significant. And then the CPU time of Cubescape is like very, very low compared to the others. And then on the memory side, then it's going to be opposite. So Cubescape, like I said, it's reporting lots of data from the kernel. So you can see that it's consuming tons. I mean, not tons, way more memory than the others. And then the memory of Falco is higher than Tetragon, and CubeArmor, where it has the events, it's about less than Falco, and but more than this piece, which is like I said, uh, Tetragon. Sorry. So so at the end, you can see that there are solutions that consume not so much on the user space, but then they start consuming way much resources on the kernel side. And even if it's nothing, we have to consider the fact that it's the kernel has a high, sometimes more priority on I mean, very often priority to the user space, meaning that you could basically do what we called it the noise, and then put impact on the way the CPU is distributed to Kubernetes, and then at the end you can have impact to the actual Kubernetes workload. So that was the thing. If you, I wanted just to share here. You
Okay.
see, remember with all the, oh, yeah, that was the results. So I did it right. The results with Kubescape and CubeArmor. So CubeArmor was about 30 milliseconds compared to without the events.
Yeah.
Um, so that's about the resources. So my stuff with the resource usage, if you apply policies on the security part, on this from a security perspective, when you play with Tetragon, you realize that you can do tons of things, and you say, oh, I can do monitoring, I can capture the network, the traffic between one namespace to the other. I can You can start taking Tetragon for other purposes, but then it comes with a price, because at the end you're putting more pressure and more things going to be added as a K probe or user probe or whatever,
Hmm.
and that has an impact. So I think if user are trying to define policies, they should define precisely which policies they really want to apply. They need policies, but putting everything without control, I don't think it's going to be a very smart strategy.
Effective.
Yeah,
Yeah.
yeah.
Um, yeah, go ahead. Sorry.
No, here's the results of the benchmark. So I didn't cover the documentation, the design experience, all the things related it. But for I would say that if you are new into the security space, you don't know so much things about eBPF. I think Kubescape is pretty great in a sense where it's simple and doesn't require configurations, and it covers not only threat detections, it covers everything that you may want to have in your cluster. So that's why my conclusion for the second benchmark. But then if you are like a network engineer and you know pretty much everything about kernel because it's your passion, then Tetragon is just fantastic. But it has a significant um, onboarding process, I would say. So that's why I think Tetragon is a beast. But if you can be afraid if you start using it. But I think in terms of extensions and what you can achieve, it's just wow. It's a beast on that regards. Um,
Cool.
one last thing.
Yeah.
I wanted to cover how do you measure the CPU, the eBPF
Yeah.
footprint. And so during the benchmark, the one that we have been sharing, I'm using Inspector Gadget for that. Inspector
Hmm.
Gadget is technology that you should know if you're dealing with eBPF. Few releases back, they had an old architecture for their gadget. So gadget is an image to simplify it with the eBPF program that you can then trigger in the Inspector Gadget. So it's a very smart way of building things. He has a gadget to troubleshoot your cluster, and he had a gadget, so you can install Inspector Gadget as a kubectl plugin, and then you can use this command kubectl gadget top eBPF. That was basically like a top command, putting all the eBPF that happens on over the nodes and the type of eBPF programs, who triggered it. So a lot of details. So when I did the benchmark, I didn't have the new architecture of Inspector Gadget was not there yet. So I had to rely on this approach where I had a job with a pod. That pod has kubectl plus the inspector gadget installed, and it was running in the background kubectl gadget top. So at the end, it produced on SD out all the results, and then I had an OpenGPT collector that
Okay.
was reading the std out of that container to collect all those data, and then I use Dynatrace to translate that data into metric and then enrich it, blah blah blah, and that's it. Now today, it's amazing because they have refactored this gadget architecture. Now they have the options where a gadget can they have a logging and metric component, so every gadget could technically emit by default logs and also metrics. And they have this new one of those gadgets that has been rebuilt called BPF stat. And also to deploy it, it's just straightforward. So it's a config map. So you deploy the config map. You say, oh, I want to use, in my case, the BPF stat gadget, the latest version. And then you say, oh, I want to collect the BPF stat metrics, and please export it to a metric exporter. So at the end, when you configure inspector gadget, you define, oh, I have an endpoint for my metrics. Could be Prometheus or it could be Open Telemetry, and then it will automatically emit it. So then the actual metric collections and the way you produce those metrics is straightforward. So you don't have to go through those complicated routes that I've done. And by the way, if you want to have details about this, I have oh, that's not the repo. Oh yeah, that's not the repo. Where yeah, it's behind the scene. I think it's behind. Yeah, here. I have the dedicated episode that I released. I don't know, or don't remember when, but I released it on the Inspector Gadget, and it covers on how you can produce metrics and traces, not traces, metrics and logs. So if you want to look at it, it's
I
on
will,
my
I will add it to the link, to the notes on HackMD so people can actually
sure.
access it.
So that's about it. Of course, I can talk more, but
No, we have many questions actually, so we can cover them if you want to.
yeah, sure.
I actually have one question first. Is that we saw that eBPF memory and CPU usage is very different depending on the security agents. And I know from Tetragon that there are some stuff that are actually handled in the user space and other on the kernel side when it's actually running. And I was wondering how much do we know about the other agents, how it is distributed, and how much like syscalls there are to actually retrieve data on maps and stuff like that. Do you have any insight on that?
Uh that's no, I
Which could
don't.
explain like
No,
the behavior behind.
I don't. In fact, it gave me an idea. I need to rerun it and then report the number of syscalls that are running in the background, so then I can measure the difference between. Oh, that could be an interesting way of doing it. I
Okay.
never thought about it, to be honest. It's a good point. But in general, they are Tetragon is one of them. They are a solution that consume almost nothing on the user space, but
Yeah.
they are mainly eating resources on the kernel. And then you have other solutions where they are more on the user space, which is the case of Cubescape for most of it.
Hmm.
But because they are collecting so much data and so much information between
Yeah.
their agents, that's why they're eating also a lot of memory. So I think it's more about the design itself of the solution, how it's
Yep.
been, what's the purpose of this.
Hmm. Okay. And so we have other questions from the people that who join us. So Hubbard Hubbard said, can I trouble you for the link to the Git repo? I guess you got trouble to access the Git repo. So I will add it to the notes on HackMD so you can access it and run during a very cloudy and rainy day. And he said also excellent content. Hello from Salt Lake City. Thank you. Insider9, I know this name. Hi, Donia. Hi, Henrik. Are these basic policies from different tools detecting the same events? I think that we might answer this question already.
Yes, that was the idea about trying to be as much aligned between each solutions. But when I hit into issues, I had to get rid of policies. That was mainly
Hmm.
in Tetragon. I didn't have that problem. It
Because
was
of the
more,
granularity, I guess.
yeah, and there was more on Cube Armor.
Okay,
Um, so I mean, Cube Armor is a really interesting solution. I think it's very promising, but I I I, I, I that's my personal message. It's not a
of course.
but
It's
I didn't.
opinionated. I was.
Yeah, it's very opinionated. I did enjoy much configuring Cube Armor compared to the other solutions. I struggled, even it's very simplified compared to Tetragon. It's but I didn't have I didn't succeed to do what I was wanted to do. So that's my feedback on Cube Armor. But
Okay.
otherwise, I think I tried. So I think Tetragon is very overcomplicated. But once you have spent your time sweating, destroying things around your desks, then you start to enjoying it. I
Okay.
think if you I think it's a tool that you need to suffer to enjoy it.
Okay.
That's that's how
Good to know. What is the difference on the conclusion slide between security requirements and security, again, from inside a nine?
so um, I think Falco from a pure security perspective. I think it's because of the design of this product. But they introduced Talon where they can react and block things. But I don't know if you know, but Falco is not actually a runtime agent. It's a rule based agent. So it's going to act. So it receive an event from an external plugin, and one of their plugin that comes by default is their kernel agent that produce those that has eBPF, and then it sends to that server rule engine, and then it says, oh, okay, it matched one of the rule, and then it produced the event. So at the end, as a consequence, so it means that the event happens, goes to the server, and then sends back to Talon, and Talon says, oh, we need to react. And so at the end, I think there's at least a few milliseconds that goes. So then you react, but is it going to be too late? That's my big question. So that's why I think on that regards, maybe they have improved it, but I think they were discussing on improving it. I think having this way of detecting and reacting straight away, like Tetragon can do, and or Cube Armor is fantastic. The other tools are not reacting specifically, but sometimes you don't want to react. You want to. It's like a camera. You aware of things, and then you can take actions. Um, but uh, but yeah, I think
So,
that's a major difference. Um, I think if you look at what Ben reported, is
mhm.
that he said that there is tools that are very noisy. So detects.
So is it here the difference between security requirements and security? Do you mean that there are actually only requirements for
I mean,
these kind of tools?
no. For me, it's more about the efficiency on the security side.
Okay. Okay. Okay.
But from yes, and otherwise from a security perspective, yes, all those tools. I mean, you're using eBPF, so you will need a significant number of capabilities, and I mean, not as significant, but in terms of privileges,
Very
it's
high.
very high. So
Yeah.
I think they are pretty much aligned on that regards. I'm more concerned about the fact that I have something happening. Can I block it before anything dangerous could happen? And
Hmm.
that's the difference. And also, Ben took the angle, says, do I really have the event detected first of all? So the balance of how many things has been officially detected and how many things has been just noise. So I think there are a lot of tools that are very noisy, and needs to be very fine tuned to say, oh, don't put some throttling, generate this and not that, and because otherwise yeah, I mean, as a normal user, if we receive millions of logs per second, then you don't even look at it anymore. That's the problem.
Okay. Um, Herbert, they said thank you. Thank you to you for your questions. And I think that we actually answer all the question in this thread. Um, I had other question. No, no. I mean, we answer all the question. Is there anything that you would like to add before we conclude?
Related to today's topic, or
Yeah, related to this topic.
no? I think no, nothing special. I think just one thing is, if you're I think if you're building eBPF programs in general, so not specifically to security, I think it's very important to measure um, their consumptions and their potential impact, because at the end, kubelet is only looking at what happens on a user space. So if you putting a bomb in the kernel, then kubelet will look very happy and won't complain. But in the
Under the hood.
under the hood, in the kernel, it's something bad is happening, and then your node won't respond, and it's going to be a nightmare. So I think it's very important to make sure that those pro EBF programs are a safe, sane performance in terms of resources, in terms of consumptions.
Okay, thank you for all your advice. So, if you want to follow Henrik, you can follow him on LinkedIn. And also, as mentioned, there is his YouTube channel with many videos every week. And he will be at KubeCon Atlanta. And he will be at Collocated event talking about Abracadabra. That's a funny title. Turns profiling into metrics. So it will be at Observability. Am I saying no? It's
Sorry, David.
Observability Day.
Yeah.
Okay, cool. And you have two other talks about gateway APIs
Yes.
and who wants to secure clusters. And
Yeah.
I'm sure I'm gonna be there because it's gonna be a show.
It's
From
gonna
what
be,
you
if
said.
if you've been watching TV game shows in the 90s, you will love it. So if you want to win a prize, by the way, go to that session.
Oh,
There's gonna be a winner in the attendees.
okay. I will revise before coming. And so this is the YouTube channel. Is it observable? Again, many content, and you will be there also as a media, and you will do interviews from
Yes.
people.
Yep.
So if people are interested, they can contact you, I
Yes.
guess.
Yes. I have a booth. I mean, I don't have a dedicated booth, but there's a booth that CNCF gives to the CNCF media. So I will have 6 hours during the conference. I don't have the time right on my mind, but I will record, produce content about it. So I will do a live stream on probably on Wednesday. So if you are working on a completely interesting project on security, observability, anything about scheduling, Kubernetes, ping me. I would love to have you on the show, interview, get more information about what you're doing, and promote the solution that you've been building. So reach out to me.
Cool.
I would love to have you on the show.
Very cool. I'm very excited to see people later. And again, if you want to run the benchmarks or you are curious about the solution and the network policies that were applied, everything is in the repo, and you can find the links here in the reference of the episode. And actually, Inspector Gadget is here, so that's good. And that's a wrap for us. Thank you so much, Henrik,
You're
for
welcome.
joining.
And also,
And
if you just so I was just recording the new episode that will be released in few weeks, I would say, few days. For those who's working on Proxmox and running Tetragon on Kubernetes clusters on Proxmox or anything like this, reach out. I'm building a content about it, so I have a Proxmox cluster just under my desk where I'm using cluster API. So never heard about that project? Check it out. It's amazing. So if you want to deploy a cluster on Proxmox cluster in a one command line, It's amazing. So check it out.
Okay. Okay. We will have a look. Thank you so much. Bye, everyone. And see you next week.
See you. Bye.